If I look at this guy, it says determine one angle measurement if the lines are parallel. And so this time we're saying that the lines are parallel. So if I know that these lines are parallel, think about what measurement on the second line would have to be the same. And so if I look at this, if these are parallel, this one heads off at a 65-degree angle. And so if the next line is parallel to that, it should also head off at a 65-degree angle. And so the idea here is that's the measurement that I can find. If these are parallel lines, they have to head off in the same direction. They have to head off at the same angle. So I know that that is a 65-degree angle. Okay? If I look at the next one, this one's a little bit trickier because I'm not measuring it in the same way that I've been measuring these things. And so when I look at this thing, this is the line I'm using to compare them, this line in green. And so measuring off that green line, this one's heading off at a 70-degree angle off of that green line. So when I look at the other line that's supposed to be parallel to this thing, because once again, I'm saying that these lines are parallel, well, it means that this has to head off at a 79-degree angle also. And I have to measure it off of that same green line and in the same manner that I measured the first one. So this one, I measured this angle right here. And hopefully you can see that that translates to this angle right here that has to be a 79-degree angle. Okay? And so regardless of which line I'm on, if these are parallel, they should head off at the same angle measurement, all right? And so I need some kind of line to compare these from. In the previous couple examples, I've always been comparing them. I've always been measuring the angle from a horizontal line, okay? But this time I'm measuring that angle from kind of a diagonal line. And so look at how I measured it on the first line. I have to measure it the same way on the second line, okay? So on the first line, I measured it in this corner. Up here, I have to measure it in the same corner, okay? So really, I'm finding this measurement has to be the same, okay? And what we actually call these, we call these corresponding angles, okay? In geometry, that's the fancy term that we use. It's basically just saying, hey, I'm putting that angle measurement in the same spot, okay? And I have to measure from the same spot to see if these things are parallel. Same thing with this guy. If I look at this one, I measured down this time. So it's like I flipped my protractor upside down. So from the horizontal line, I measured 57 degrees on this one. If I know that these two lines are parallel, well, that means I should get the same measurement on the other line, okay? And I have to measure it in the same way. I have to measure it from the green line down. And so I have to conduct that measurement in the same way, which means this angle also has to be the 57 degrees. Okay? And so again, the idea here from a geometry's perspective is labeling these, we call those corresponding angles. Okay? They're just angles that are kind of in the same position where I'm doing the same thing for each. Okay? And then if I look at the next one, hopefully we can identify this really quickly and just say, hey, it's got to be this one up here. All right? And again, it's in the same position. If I look at this thing, I'd have to kind of rotate my protractor sideways. If I rotated my protractor sideways, I'd be measuring the angle from the green line this way. And so if I go to the next line, I have to measure from the green line this way as well. I have to measure the angle in the same manner for each of these, okay? So again, the problem told me these were parallel lines, so if they're parallel, well, then I should get the same angle measurement from each. They should go off the same angle, but I have to measure that angle in the same spot each time, and in the same direction, in the same manner each time.